Hello guys, welcome to Exam List. So in our last couple of lectures, we were actually discussing about why do we use free body diagram. Okay, and we also talked about how to know where to use the free body diagrams. Okay, so one such example is the pulley system. So let us start by understanding how to solve this kind of system. So consider this is a pulley and we have two ropes. Okay, and we have two masses joined with the pulley. Agreed. Now consider that this part has a mass m1 and this one has a mass m2, and say m2 is greater than m1. So what happens when m2 is greater than m1? So when m2 is greater than m1, obviously the object falls downward. Agreed. I mean, see, there is a force, the below you have the earth. So there is an acceleration always acting. That acceleration is g. So obviously there is a force here m2g that is actually pushing the entire m2 downward. So what is the force here? The force here is m2g. Agreed. And now when this object is moving down, now can you tell me one thing? What will be the acceleration of m2? Will m2 fall with an acceleration g? The answer is no. If m2 were alone, if nobody would have been with m2, if m2 were allowed to free fall, only then the acceleration with which the m2 would have fallen down to the ground was g. But here, through this rope, there is an m2 mass, there is an m1 mass attached with the m2, and this m1 creates problem. It does not allow m2 to fall with an acceleration g. So when the m2 is falling, it is not only falling because of its own weight, but somehow the weight of m1 is also creating problem for m2. So m2 does not fall with g because of the presence of m1. So we can say that, okay, so only when m2 is free, it falls with an acceleration g. If m2 is not free, if someone is creating some problem in m2's life, then we can say that there is an acceleration a with which the m2 falls, and this acceleration a must be less than g. The reason it is less than g is because m2 is not free. So m2 is not undergoing free fall. Now why the m2 is falling with an acceleration a? The reason m2 is falling with an acceleration a is because of the resistance, or you can say because of the m1 block attached to m2. Now how can I reflect the information of m1 block in terms of force? I mean, how can I reflect that m1 is attached to m2 by using some kind of force definition? The only definition that can carry the information that m1 is attached to m2 is the tension in the string T. So now I say that because of the presence of m1 through the rope and it is connected to m2, there is a tension which is developed in the string. This tension is developed in the string because m1 is attached to m2. If there were no m1, there would not have been any tension in the string. So this tension of the string also says that there is a mass m1 attached to m2 creating problems. So what is the net force under which the m2 is falling down? If you see clearly, if m2 were alone, then the only force that will create downward motion was the weight of m2, that is m2g. But since m2 is connected to m1, so there is a tension which is not allowing m2 to fall with g. And this tension is the reason because of which m2 is falling with an acceleration a. So m2 is falling with an acceleration a. You see, this equation is just a force equation where I've written that m2 So m2 would have fallen with an acceleration g if it was free, but due to the presence of m1, there is a tension created in the rope, because of which m2 is not falling with g, but it is falling with an acceleration a. So this is the meaning of the equation here. Similarly, look at what happens with m1. The m1 is going up. Now what velocity or acceleration m1 is going up? Obviously m1 has to go up with an acceleration a. Why an acceleration a? Because m1 and m2 are now the same thing. They are connected to string, so they are now the same system. You cannot have m2 going downward with a higher velocity than m1 going upward. This will create a break in the string. So this string that connects m1 and m2 has now made m1 and m2 a single system. So if any part of the system moves with an acceleration a, other part of the system will also move with an acceleration a. So m1 and m2 are now a system. So if m2 falls down with an acceleration a, then m1 must also go up with an acceleration a. Now what is actually causing m1 going up? m1 should have fall down. Why m1 should have fall down? Because there is a force m1g that is pushing m1 down. But the only reason m1 is going up instead of going down is because the m2, which is heavier than m1, and since m1 is connected to m2. So how to put the information? The way to put the information is that m1 would have fall down with an acceleration g if it were free, but because of m2, no, so let me not write that. Okay, now the presence of m2 can be indirectly reflected by a tension in the string up t. And I can indirectly say, instead of saying m2 is making m1 go up, I can say that this tension in the string is making the m1 go up. So now I write the tension in the string is making it go up, and m1g is trying to make m1 go down. So tension in the string is trying to make it go up, and m1g is trying to make the mass go down. So finally the tension wins and the entire m1 starts going up with an acceleration a. Agreed? Now why tension wins? The only reason tension is winning because m2 is greater than m1. Now you have done these things in your plus 2. Solve these two systems. Okay, you see, if you just add them, if you just add these two equations, so this is an equation for m2 and this is an equation for motion of m1. So if you add these two equations, you can actually find what is the actual acceleration with which the system is falling down, and you'll find the value of this acceleration is given as m2 minus m1 divided by m2 plus m1g. So look at this carefully. As I said earlier, that acceleration is less than g because there is no free fall here, and this equation is also saying the same thing. You see, m1 plus you see m2 plus m1 is going to be greater than m2 minus m1, so we have a larger value in the denominator. So when you have a larger value in the denominator, what does it suggest? It suggests that the overall value is going to be less. So there is a larger value in the denominator, and of course this value will be a value which is less than g. Look at it yourself. So put m2 as 2 kg, okay, and put m1 as 1 kg. Okay, what do you get? Obviously you'll get acceleration as 1/3 of g. You see, a is less than g. Why? Because we do not have a free falling system, we have a system attached to another system, and that two things make one system. Similarly, putting the value of acceleration a here, you can actually calculate the tension that is in the string. Amazing, right? This is quite amazing. You can actually calculate the invisible tension in the string, and this can be easily found by using the value of the acceleration a and putting the value of acceleration a in any of the two equation, and you can easily find the value of tension as 2 m1 m2 divided by m1 plus m2 g. Right? Amazing, right? So this is the value of the tension, and this is the value of the acceleration with which the entire pulley system is going down. Now in the next lecture we'll look at one more pulley problem, and we'll also try to understand why free body diagram, how free body diagram help us to calculate. So in the next lecture we'll do one more pulley problem.